2.6, we're going to talk about families of functions and transformations of graphs. So this kind of starts off with everything you need to know about this lesson, has very important information, but I'm going to explain a little bit more about what this K does, what this H does, what the A does, and the reflections about the x-axis and y-axis depending on where the negative sign is. So we're going to talk first about family of functions and what we call a parent function of a normal graph. So we're going to start off with, of course, we have y equals x, which is a linear equation. And that linear equation, okay, we'll go through the origin. This is what we call the parent function. This is the most basic type of linear graph that we can have. And then we would add different things to that, like a 3x and a plus 2. And if I were to graph this 3x plus 2, okay, compared to the parent function, what does the 3 do to it? It would make my rise over run go rise 3 and run 1. So I would still start, and then I would start at 2, sorry. So this plus 2 would be a vertical shift, and I would go up 2. And then from that point, I would go up 1, 2, 3, and run 1. So this graph from the parent function is a little bit steeper, and it translates or goes up 2. So we don't do a whole lot with linear because they're kind of tough to talk about with translations, but with other graphs such as parabolas or absolute value graphs or cubic graphs or square root graphs, we can get a better idea. So the first graph we're really going to look at here is a quadratic graph, okay? And when you have a quadratic graph, you have a graph that looks something similar to this, okay? This is what we call the parent function. Any shift or translation that we do off of this graph is based off of the parent function, which is this graph right here. We have a vertex at 0, 0, and it goes up pretty gradually to the right and pretty gradually to the left. So what we're looking at now is an equation that looks like this: a times x minus h squared plus k. And we're going to take a look at what the effect these different letters have on the graph. Okay, so A does two things to the graph. If A is negative, it's going to flip the parabola. Okay, so if A is negative, it's going to flip the parabola. Okay, if A is greater than 1, so this A, the number right here, see there's a number A right here that you don't see, it's number 1, then the graph is going to get skinnier, okay? We call that a vertical stretch. So it's going to have a vertical stretch. Okay, if A is greater than 0, but less than, let me do this the other way. If A is, okay, greater than 0, but less than 1. In other words, a fraction, okay, or a decimal that's less than 1, then it has not a vertical stretch, but it gets wider, okay? The graph is going to get wider. Which we call a vertical compression. Okay, so this is going to have, a vertical compression. So all I'm doing, A tells me one of 3 things. If it's positive, the graph goes up. If it's negative, it flips and goes down. Okay, so if it's negative, the graph will go down. If this A is greater than 1, we would say that the graph has a vertical stretch or it gets skinnier. If it's a fraction, which is less than 1 or greater than 0, we will say that it has a vertical compression. Okay, those are all the effects that A has on the graph. My H, okay, H is a horizontal shift, and it's always the opposite. I'm going to erase that, make that a little neater. Okay, so a horizontal shift, okay, and it's always the opposite. Meaning, If I have a -4 here, we always think of minus going to the left. If it's a negative inside the parentheses, we would actually go to the right. Okay, if it's a positive, we would go to the left. And then my K is a vertical shift, and that one's always the same. Okay, so again, we're always looking at this equation. So if I had an example and I said, what are the transformations given this graph? Y equals 3 times x plus 2 squared minus 4. Okay, what is my A? A would equal 3 here. Okay, well, is A negative? So no, we would not say that it flips. Okay, so we wouldn't say it flips, but what does it do? It has a vertical stretch of 3. Okay, then I look at my H. What is my H? My H is plus 2. Plus 2 would normally tell me horizontally go to the right, but this would shift left 2 units. Okay, and then my K is a -4, which means it would go down 4. So again, if I were to graph this next to my parent function, okay, next to the parent function, the vertex of the parent function is 0, 0. The vertex of this graph would be left 2 and down 4. How did I get the vertex of left 2 down 4? Again, from my H and my K. My H is plus 2, which tells me to go left 2. My K is -4, which tells me to go down 4. So then now what would it look like? Would it have the same exact shape of this graph? No. The A is 3, so it's going to be skinnier. So the graph is going to look something like this. And again, this is a rough sketch, but you can clearly see that this graph is skinnier, okay, and the vertex went left 2, down 4. So that would be for a squared graph, okay? Now, if we look at a cubic graph, and again, you're going to get kind of sick of me saying this stuff because it's the same thing over and over again. Y equals x cubed. Here's the parent function. The normal graph would look like this, okay? Normal graph would look like this. So what does the standard form of this graph look like? X minus h cubed plus k. Do I need to write out what A does to the graph? If A is greater than 1, it's going to do what? It's going to make the graph skinnier or vertically stretch. If it's negative, it's going to flip, okay? What is the H going to do to the graph? If it's a plus, we move to the left. If it's a minus, we move to the right. And K would be my vertical stretch. So again, just looking at a problem like this, -1/2 x plus 2 cubed minus 4. So if I looked at this graph, what does the -1/2 do? It's going to flip about the x-axis. Okay, so this is going to flip. It's also, because it's 1/2, it's going to have a vertical compression. Okay, which in normal terms, it's just going to make the legs of this thing a little bit wider. Okay, so it's just going to make it a little wider. What is my H? H is plus 2, which means I'm going to go to the left 2. And -4 is going to tell me to go down 4. I think I did the same thing last problem. Same exact numbers, okay? So if I take a look at this graph, again, where am I getting these numbers from? It's going to flip about the x-axis. So this is, instead of going up, is going to go down, okay? It's going to be a little bit wider. Now, there's no vertex here. What am I moving? I'm moving this center point right here. So I'm going to go left 2, okay, and I'm going to go down 4. So my center point's going to be here. Instead of going up and to the right at a normal length, I'm going to go down and to the right, and it's going to get a little bit wider because of the 1/2. So it's going to look something like this, okay? There's that leg, and then this leg would go up through. And again, you can always check these graphs on Desmos, but really the key is knowing your H, your K, and your A as we're going through these problems, okay? And A, H, and K always have the same effect. And I always say H is on the inside, and I just say inside because sometimes it's parentheses, sometimes it's a radical, sometimes it's a square root graph. Okay, so let's take a look at the next graph. Y equals square root of x. So what does that normal graph, the parent function graph, look like? Starts at 0, 0, kind of has a half of a sideways parabola. Okay, so again, what would the standard form of that look like? X minus h plus k. So again, this h is inside the square root. The k is on the outside. Again, a has the same exact effect. So if I went y equals negative square root of x x minus 4, and then a plus 1 outside here, this negative would flip. Okay, so it's going to go down instead of up and to the right. It's going to go down and to the right. This minus 4 is going to make it go 4 to the right, or right 4, and this plus 1 is going to make it go up 1. Okay, so if I were to graph this, it's going to go 4 to the right, 1, 2, 3, 4, and up 1. So this starting point right here is going to go right 4, up 1. And then now, because of this negative, it flips. Now, does it get wider or skinnier? No. It stays about the same exact shape because my a is negative 1 here. Okay. Let's take a look at another graph. That graph is a cube root. And that graph is going to look something like this. Okay. It's got that half. It's kind of a sideways, looks something like this. Okay. There we go. Okay. So again, what does the standard form look like? X minus h plus k. A, same effects, wider, narrower, flips it. Okay, x minus h, inside the h is going to be a shift left or right, and the k is going to move it up or down. Okay, so again, do an example, 1/3 square root of x minus 1 plus 4 on the outside. What's that going to do? It's going to give it a vertical compression. Okay, the minus 1 is going to make it go to the right 1, and the plus 4 is going to make it go up 4. So again, if we got Desmos out, and we did one of these problems on Desmos just to check it. So vertical compression, this 1/3 makes it go a little bit wider. Okay, so vertically compresses. It's going to go, the graph's going to look something like this. Okay, vertical compress, so the 1/3 is going to make it wider. It doesn't flip at all, but it is going to move to the right 1 and then up 4. So it's going to start here and it's going to get a little wider and do something like this. Okay, these ones are a little bit harder to see just because of the shape of the graph, but that they do vertically stretch. Okay, or vertically compress there. Last one that we're going to talk about is an absolute value graph. Again, what does an absolute value graph look like? Absolute value graph is a V-shaped, so y equals absolute value of x. The parent function simply starts at 0, 0, goes up 1, right 1, up 1, left 1, and forms that V. So what would the standard form look like? X minus h plus k. A flips it, h shifts it left or right, k makes it go up or down. So you give an example like this. What does A do? Well, it's negative, so it's going to flip about the x-axis. Okay. It's a 2, which is greater than 1. Okay, the negative flips it. The 2 is what I'm looking at. It's greater than 1. So it's going to make it skinnier or vertically stretch it. So it's going to have a vertical stretch by 2. Okay, it's going to go left 5, and it's going to go down 3. Okay, so again, that new graph would look something like this. Left 5, 1, 2, 3, 4, 5. It's going to go down 3. Okay, so there's where the vertex would be. Then it's going to be a little bit skinnier, and it goes down because it's negative. So it looks something like this. If all I did was ask you to explain it, then this would be what that graph would look like. Okay, so I'm going to put another video up that goes over some of the homework problems, but this right here is your notes. You should be familiar with the 5 different functions that I gave you. The linear, here's the parent function. The quadratic, here's the parent function in black. Okay, the cubic function, again in black, kind of looks like a little line running through 0, 0. The square root function, the cubic function. Okay, and of course the absolute value. Please don't- The heck is that?